Hello, my name is Dr. Chernykh Volodymyr. I'm an aesthetic practitioner and I've been practicing in the field of regenerative medicine for the last 10 years. Here today I prepared some general questions, some basic generalities about the stem cells, and we've been asked these questions many times. So basically today I decided to collect some of them, and hopefully it's going to be helpful for you in the future. Stem cells are undifferentiated cells that can develop into different specialized cell types in the body. They are characterized by their unique properties of self-renewal and differentiation into specific lineage of cells. Self-renewal or self-replication means that stem cells can divide and produce more identical stem cells, allowing them to maintain a pool of undifferentiated cells. Differentiation refers to the process by which stem cells can transform into specific cell types with specialized functions, such as nerve cells, muscle cells, blood cells, and many others. Stem cells have attracted significant attention from researchers and medical professionals due to their potential for regenerative medicine, recovering and rehabilitation from different diseases, for the maintaining of the general well-being, disease modeling, and drug discovery. They offer the possibility of replacing damaged or diseased cells and tissues, as well as studying disease in a lab setting to understand their causes and develop new treatments. Well, I would say that using rabbit stem cells or using sheep stem cells for xenogeneic cross-species transplantation has several potential advantages. Firstly, it is an availability. Rabbit stem cells or sheep stem cells can be obtained more easily and in larger quantities compared to certain other sources of stem cells, such as human or stem cells derived from the other animals. This availability makes them more accessible for research and potential clinical applications. So the second factor is an immunological advantage. So rabbits or sheep are phylogenetically distant from humans, which means there is a reduced risk of immune rejection compared to using stem cells from species closer to humans, for example, primates. This decreased immunogenicity may allow for greater compatibility and a potentially lower risk of immune system complications. Next is safety, of course. And of course, we are following the main principle in medicine: no harm. Using rabbits as a source of stem cells for xenogenic transplantation offer a safe alternative compared to using stem cells from other animals that may pose a higher risk of disease transmission. And I like to emphasize, in our practice, we use specific pathogen-free animals only. Specific pathogen-free or SPF animals refer to laboratory animals that are carefully bred and maintained in controlled environments to ensure they are free from viruses, bacteria, parasites, and other pathogens that might interfere with scientific research. SPF programs typically involve rigorous testing and monitoring to ensure the continued health and pathogen-free status of the animals. This commitment to quality insurance helps maintain the integrity of the stem cells derived from these animals. At the same time, the risk of zoonotic transfer, the spread of diseases from animals to people, is reduced when SPF animals are used, guaranteeing that any stem cells obtained from these animals are less likely to contain infectious agents that could be dangerous to humans. So, these are the main points to mention in answer to this question. Mitochondrial peptides or mitochondrial targeted peptides have gained attention in the field of medicine due to their potential therapeutic effects on diseases. And now let's discuss some reasons why these peptides are being explored for the treatment of multiple conditions. The first and most significant factor is that mitochondria, sometimes known as the cell's powerhouses, are essential for producing adenosine triphosphate, ATP, which is the energy source, for every cell. Numerous diseases, including those connected to the nervous system, the heart, the metabolism, and aging itself, have been linked to dysfunctional mitochondria and their development and progression. Mito Organelle peptides are made to specifically target and interact with mitochondria in order to improve their performance and get cells making energy again. Then, mitochondria are found in practically every cell in the body and they are involved in a variety of cellular functions other than the synthesis of energy. They are involved in the regulation of calcium homeostasis, oxidative stress response, cellular signaling pathways, and cell death or apoptosis, and more functions. So Mito Organelle peptides may be able to influence these processes and have a wide range of effects on many organ systems by targeting mitochondria, which could have a positive impact on a variety of disorders. Simultaneously, we are aware that oxidative stress and inflammation are prevalent underlying causes of numerous diseases and that mitochondrial malfunction can lead to these conditions. And it has been discovered that Mito Organelle peptides have antioxidant and anti-inflammatory properties, which may help lessen these negative effects. These peptides may promote cellular health and provide protection against harm to a variety of organs and tissues by lowering oxidative stress and inflammation. Lastly, but equally importantly, mitochondria are involved in the process of cellular regeneration and repair. Mito Organelle peptides can boost mitochondrial biogenesis, improve cellular metabolism, and activate tissue repair pathways, all of which can increase a cell's ability for regeneration, for its successful regeneration. Their capacity for regeneration makes them potentially beneficial for conditions involving loss of tissue or degeneration, including, but not limited to, neurodegenerative diseases, cardiovascular diseases, musculoskeletal injuries, and so on and so forth. Furthermore, they work incredibly well to regenerate the skin. I use them a lot in my daily practice as an aesthetic practitioner. Trials have shown that the mesotherapy with the mitopeptides is a useful technique for reducing wrinkles, age spots, scars, and other symptoms of aging skin aging. Because of all these different beneficial aspects, mitopeptides are a very helpful tool in the field of regenerative medicine. There are a few things to think about and bear in mind when comparing organ-specific targeted fetal xenogeneic stem cells with mesenchymal stem cells and umbilical cord stem cells. So, a differentiation potential and efficacies come first. Targeted fetal xenogenic stem cells that are unique to an organ or tissue are produced during the fetal development stage. These cells are more highly specialized, and there is a far greater range of disorders that can be treated using xenogenic stem cells. It is true that mesenchymal stem cells can differentiate into a few lineages of cells, but still their differentiation potential is limited to such cell types as osteoblasts, bone cells, chondrocytes, cartilage cells, and adipocytes, fat cells, as well as other cell types such as myocytes, muscle cells, or neurocytes, as we know as the nerve cells, and stromal cells only. Furthermore, there is never an assurance that the MSCs will mature into the specific cell lineage that a given person needs. At the meantime, only blood or immune issues can be treated using umbilical stem cells, and a single cord blood unit has only enough stem cells to treat a child up to the age of 10. The approved treatments for autologous cord blood cell therapy include Waldenstrom's macroglobulinemia, NHL, multiple myeloma, and particularly its aggressive variant, plasma cell leukemia. The remaining therapeutic uses are either allogenic or are presently being investigated in experimental, animals or clinical trials a given person needs the most. It is important to note that the therapeutic effects of MSCs and umbilical cord stem cells can vary depending on factors such as the source of cells, the administration method, the disease context, and the specific patient characteristics. Unfortunately, although clinical trials of MSCs have met safety endpoints, efficacy has not been demonstrated in many cases. The second factor to discuss is tissue compatibility and immunogenicity. Compared to fetal xenogenic stem cells, MSCs and umbilical cord stem cells are slightly better at being immunologically compatible and less likely to cause immune responses. Sometimes the use of xenogenic stem cells from different species possesses certain challenges in terms of immune rejection, like a non-lasting fever requiring additional measures to mitigate the immune response. However, it is possible while injecting other types of stem cells as well. That's why, in certain cases, pre-medication is required before starting the implantation. But, in general, fetal stem cells show very low immunogenicity. It is important to note that the choice of stem cells type depends on several factors, including the specific medical condition, the desired therapeutic goals, and the available resources and expertise. Each type of stem cells has its own advantages and disadvantages, and ongoing research aims to uncover the full potential and limitations of each cell type for different application. It's a complex question, so I'll go step by step. Answering the first part, I should say yes, it is possible to transfer mesenchymal stem cells from one individual to another. Allogenic transplantation is the technique of infusing MSCs from a donor into a different recipient. Obviously, in this case, the donor and the recipient are genetically distinct people. The recipient's body can still benefit from the injected MSC therapeutic actions, which include enhancing tissue repair, lowering inflammation, and modifying the immunological response. It's crucial to remember that allogenic transplantation carries some hazards, including the possibility of immunological rejection and graft versus host disease, GVHD. Immune rejection occurs when the recipient's immune system recognizes the transplanted MSCs as foreign and mounts on immune response against them. GVHD can occur when the transplanted MSCs recognize the recipient's tissues as foreign and attack them. Also, it's best to consider having the cells from the younger donor possible, as the MSCs show a decline in function and epigenetic regulation as we get older. Because of this, it is preferable to employ organ-specific xenogenic stem cells produced from fetuses to maximize the benefits of stem cell therapy. These fetal cells exhibit a number of advantages over MSC cells, including a high level of readiness to differentiate and undergo changes in response to environmental stimuli. They can maintain their epigenome throughout generations while also acting in line with the recipient's epigenome. I would also like to add that because of this tissue plasticity, they also exhibit easy adaptability in terms of growth, migration, mobility, and the capacity to establish cell-to-cell contact. They also exhibit the highest frequency and speed of cell division and proliferation, both of which decrease with the further development. These are not the only advantages of employing fetal stem cells though. It's a matter of fact, which has been confirmed in multiple trials, that the xenogenic targeted stem cells are extremely effective in the production of various biological substances, for example, like growth factors, that facilitate the survival of cells after implantation and stimulate damaged tissues and organs of the host. What else? Immunogenicity is so much lower, resulting in much weaker immune response in the host as compared with the implantation of cells of adult origin. Additionally, and it is just as important, the fetal cells show that they can live with less oxygen and energy from glycolysis alone, which is very important in the first few hours after implantation. There are several reasons why some recipients of stem cells injections may not experience appreciable improvements in their health. To name a few, various individuals may experience different outcomes from the stem cell therapy. Alright, so the outcome can be influenced by a number of factors, including the patient's age, the type of stem cells employed, the underlying diseases, the specific condition being treated, and the individual's overall health. Some individuals may experience noticeable improvements, while others may have more subtle or limited responses. Furthermore, to get the best results possible, some illnesses may require several therapy sessions or extra supportive therapies. Certain individuals who receive injection for the purpose of preserving their well-being and do not suffer from any chronic or debilitating illnesses may not notice significant improvements in their condition, particularly if they maintain a healthy lifestyle. The availability of stem cell therapy in public hospitals and its legal status vary from country to country. There are certain reasons why stem cells may not be widely available in the public hospitals or may be banned in certain countries. First of all, stem cell therapy is a rapidly evolving field, and there is still ongoing research to establish the safety and effectiveness for various conditions. It takes time for new treatments to go through rigorous clinical trials and regulatory approvals before they can be widely adopted in public hospitals. Secondly, we need to mention that different countries have varying regulatory frameworks and guidelines for the use of stem cell therapy. Some countries have strict regulations in place to ensure patient safety, efficacy, and quality control. The regulatory process may involve thorough evaluation, clinical trials, and approvals from health authorities before therapy can be provided in public hospitals. In some cases, the regulatory bodies may take a cautious approach due to the concerns about safety of ethical considerations, which can delay or restrict in a way the availability of stem cell therapy. At the same time, stem cell therapy can be expensive and resource intensive. Public hospitals often have limited budgets and resources, and they need to prioritize treatments that are proven, cost-effective, and can benefit as many patients as possible. The high cost of stem cell therapy, along with the need for specialized facilities and expertise, can make it challenging for public hospitals to offer these treatments to all patients. Here, we won't mention that the massive big pharma companies also do not want stem cell therapy to be a grand player on the market. Also, some countries have strict regulations or bans on specific types of stem cell research or therapies based on ethical or religious grounds. It is important to remember that as science advances, more data accumulates and laws are changed, the accessibility and legal standing of stem cell therapy may change. In the future, stem cell therapy might be more widely available in public hospitals when research and clinical trials are being carried out. While I hope this day will come, unfortunately it is not possible at the present. Well, it's a good question. It is important to note that not all doctors are pure scientists, alright? And most of them specialize in their particular fields of expertise without gaining knowledge from other disciplines. Certain stem cell types, such as embryonic stem cells, have not been employed since the 90s because of the high-risk possibility that they could generate cancers like teratomas. Naturally, some patients undergoing stem cell therapy can already have certain underlying medical disorders or genetic abnormalities that raise the risk of cancer. These pre-existing conditions or mutations may interact with the introduction of stem cells or genetic alterations, increasing the likelihood that the cancer will develop. For this reason, any prescription for cells ought to be made only after careful assessment and inspection. It is critical to emphasize that, despite its dangers, stem cell therapy has demonstrated promise in the treatment of a number of illnesses and has the potential to completely transform medicine. To guarantee the security and effectiveness of stem cell treatments, scientists and regulatory agencies are still working to improve procedures, carry out thorough investigations, and create guidelines. No, it is biologically impossible. The DNA and genome of the host do not change as a result of introducing foreign cells, such as xenogeneic or, as we know, animal stem cells. And it doesn't happen for several reasons. First of all, the DNA and genome of an organism are present within the nucleus of its own cells. Injecting foreign cells, even stem cells, does not directly modify the DNA contained in the recipient cells. Secondly, injected xenogenic stem cells are unlikely to integrate their genetic material into the recipient cells. Integration refers to the transfer of genetic information from one cell to another, resulting in change in the DNA of the recipient. While certain gene editing techniques exist, they require specific targeting and deliberate manipulation of the DNA. Then we need to add that stem cells have the ability to differentiate into specialized cell types, but this process does not involve altering the DNA of the recipient. When transplanted, stem cells may interact within the surrounding environment and differentiate into specific cell types to perform their intended function. However, rather than altering the recipient's DNA, intrinsic, I'd like to emphasize only intrinsic cellular mechanisms and signaling cues are what guide the differentiation. The agglutination reaction can be given as an example. When foreign blood is transfused into the human organism, which is a form of cell therapy as well, only the agglutinins of the recipient will perform an agglutination reaction with the blood cells of the donor, but never the other way around. Another reason why xenogenic transplantation won't cause any changes to humans' DNA is because changes to an organism's DNA that can be passed on to the future generations typically occur in germ cells, which are sperm or egg cells, rather than somatic cells, which means non-reproductive cells. Injecting foreign stem cells into the body predominantly affects somatic cells and does not impact the DNA of germ cells, thus not leading to heritable changes. Next absolutely fascinating fact to think about is that even though insulin is originally obtained from the pancreases of cows or pigs, and heparin is typically derived from the mucosal tissues of the same animals, almost no individual would think about a possible future change in their DNA when administering injections. And last but not least, it is important to note that genetic modifications and alterations to an organism's DNA require specific techniques such as gene editing or genetic engineering that are carried out intentionally and with precision in a laboratory setting. Natural biologic processes, such as introducing foreign stem cells, do not spontaneously cause changes to an organism's DNA or genome.